Uh, what comes next is about addition of vectors. As I was telling you the other day, there's no way that we can add vectors like just adding 140 with 150. Okay, that's that's not correct when we're talking about vectors. The reason is because vectors have two characteristics. They have a magnitude and they also have direction. Okay, so you cannot add them because they must be you must take them separately. You must treat the vectors separately by their components. So, for example, if I tell you, let's meet at the cafeteria, okay? And this is the cafeteria. I didn't specify the exact place, okay? And I'm located at this table, and you came in this, okay? You came at this position. There's no way that we could meet. If you stay in the same place, there's no way that we could meet. What I can do is walk to the right, and then I know it's not vertical, but I will say vertically down for that saying to meet you. That's what I could do, or you could do it in the other way. Okay? You can try to meet me by walking to the left and north. That's what you could do to meet me. So in vectors, they must run in the same ways. That means they must move vertically but also horizontal. To add vectors, we need to treat them separately. For example, here I have a vector. I'm going to freeze this image. Okay. So I have this vector A and vector B. Okay, the idea of adding vectors is um, you need to work with them as we were doing components, okay? So you're going to take each vector separately. You're going to work with them separately. For example, the first vector, I'm gonna place it here. My first vector is A, and it's called A, and it measures 150 Newton. This is my vector A. Okay. What I know about this vector? I know that it has an angle. Where is the angle located?
At the y-axis, so it's vertical.
Is touching the y-axis, so it's vertical. So you already said one very important thing, that is, I have a vertical angle. If you have a vertical angle, how are my components going to be calculated? To calculate the x component, you're going to be using what trigonometric function? Cosine or sine?
For the X sign.
For the x, sine. The reason is because it's a vertical angle. So this is going to define the formulas to use. Okay, this is going to define the formulas to use. So for x component, okay, you will say my angle of 70 for my vector of A is going to have this component ax going to be equal to hypotenuse sine of the angle. I repeat, this is because It is a vertical angle. And to find the y component, AY gonna be equal to hypotenuse times cosine of the angle. I repeat, in this case, because cosine is in here. Okay, my x component is this one, and it's touching the angle. That's why we're using cosine. Or you can just apply the formula for vertical angles. That is, for y, cosine. For x, sine. What is the hypotenuse of the angle A, of the vector A, sorry?
150 newtons.
150 Newton. That's a hypotenuse. Hypotenuse, remember, it is the magnitude. Okay? And then we have the sine of the angle. The sine of the angle that is 70 degrees. So in your calculator, how much is this?
140.95 newtons.
140.95 newtons. Okay, now let's analyze where the vector is going. Is going to the right or to the left?
Right. Right.
It's going to the right. So that means that in x is going to be positive. Okay? In x is going to be positive. It's going up or is it going down?
Up. Up.
It goes up. So in y is going to be positive or negative?
Positive.
Positive. So my two components are going to be positive. Now, I'm going to use a different blue. Okay. It's going to the right, so it's positive. Because this is your final answer. Well, not your final answer, by the way. The final answer is when you get the resultant in angle. I'm just going to put it like that. Component y is going to be AY equals hypotenuse. What is the hypotenuse?
140 newtons.
150 Newton. We're talking about the same vector.
Yes, sorry.
Yes? So don't worry. It's the same vector. We're talking about the same vector of 150 Newton. So the hypotenuse is the same, 150 Newton. I said 40, but it was 50. Okay? And then we have the cosine of the angle. Cosine of the angle that is 70. AY is equal to
94.95, sir. 95.
95.
Yeah, rounded will be 95.
Exactly 95.
It's because the answer is 94.997, so if we round it, it will be 95.
Miss, I get 51.30.
51.30. Yes, it's
Yeah,
51.30.
that's what I'm getting times 150. I'm gonna do it again. I'm getting 51.3.
30.
Uh-huh. So the person who said 95 tried to do it again.
It used to be the same answer, 94. Look, and I think I do it like that.
Maybe your calculator is in radians or made your calculator to be in degrees by pressing mode, and when you see degrees, press the number that is mentioned. Mode until you see DEG, press that key. Okay. Because the procedure that you showed me looks okay. But maybe your
Yeah,
calculator
no,
is
yes.
okay. Okay, very good. 51.30, we're talking about units in Newton. We say that the vector is going up. Because it's going up, it's going to be positive in y. And so this is your, not your final, but your, let's say, a prior answer. We say that that's what we have. So from the procedure that I did, do you have a doubt? You can directly unlock your microphone and say your doubt. Does the whiteboard look good? Looks good?
Yeah.
Okay, let's focus on the getter.
Miss, the side of the vector will, if the side of the vector change, in this case it's vertical, but if in another exercise is uh, horizontal, the x and y component will going to change of or place or sign, or they will going to change it. The vector is in another position that is not vertical.
Well, if it's not a vertical angle, then it's horizontal angle. When that happens, just remember this. When you have vertical angles, your x component is with sine, and your y component is with cosine. That's when you have a vertical angle. When you have a horizontal angle, your x component then is going to be using cosine, and your y component is going to be using sine. That's like the rule that I wrote on the board the other day. So remember this. When you are doing the x component for horizontal angle, then you have to use the trigonometric function cosine. And for y, sine. This is not the case yet. But if you notice, in the second vector, this second vector is in this direction, going in this direction. Okay? It is called vector B, and it measures, or it has a hypotenuse of 140 Newton. Also, this vector has an angle that is 35 degrees. So I complete the triangle. Tell me, what kind of angle is this? Vertical or horizontal?
Horizontal.
It is horizontal because it's touching this x-axis. Okay? Remember that this is y-axis, this is x-axis. So this angle is touching x-axis, therefore we say that this is a horizontal angle. Because it is horizontal, we are going to apply the rule that I just wrote over here. Okay? That rule says that if you need to get the x component, you have to use cosine. So in other words, to get the x component of the vector b, it's going to be the formula, but using cosine. If you're going to get the component, the vertical component for the vector b, by is going to be then hypotenuse of the vector times sine of the angle. That's the application of the rule. From this, you're going to replace by the givens. Okay, bx then is going to be equal to, what is the hypotenuse in this case?
140.
140. And then cosine of the angle. This angle is 35 degrees. So this is going to be
114.68.
114.68. Yes, very good. Okay, where is this vector going? Is it going to the right or to the left?
Left.
Left.
Okay, yes, this vector is going to the left. Therefore, the angle, the sign is gonna be negative because it's going to the left. Now, by, it says hypotenuse, sine of the angle. Hypotenuse is 140 Newton. And sine of the angle is sine of 35 degrees. 35 sine times 140. How much is this?
80.30.
80.30 Newton. Now, where is the angle going? Is it going up or down?
Up.
It's going up. So it's going to be positive. Okay? Now, the next step is you are going to add vertically each column. Okay? That means that you're going to add every x component and every y component vertically. Okay? So you're going to add 140 plus negative 114.68, and this is going to give you all your total in x.
It's 26.27 Newtons.
26.27 Newton. As you can see, this is positive. Okay? It is a positive value.
In Y, it's negative 29 Newtons.
In y is positive because you are adding just 2 points.
13.16.
No, the two are positive.
131.6.
131.6.
131.6 Newton or 0.6 Newton. Why? Because in here, y is positive and by is also positive. So you add the two of them and you just write the sign.
You wrote x instead of y.
Hmm?
You wrote x and the y
Ah,
component.
yeah. Thank you. It's not me if I'm not making mistakes. It's me proving that it's just me. I'm not a clone. Same Martinez as usual. Now, next step is, remember, next step is you get the addition of each component. This is the total. If you have more vectors, you're going to have to add more components. Here we have just two vectors, and then we apply the formula to get the resultant. Okay, so I apply the formula for resultant. I'm going to do it in a different color, but no, siempre verde. Resultant is equal to the values that you obtain in x, which is 26.27 Newton to the second power, plus 131.60 Newton to the second power. How much did you get? You can type it in the chat if you already have your answer. Very good. Fabiola, you need to get a square root of the answer you got. Mauricio, you need to get the square root of the answer that you sent. Don't forget, this square root is not invisible. Xavier, too. Okay? The square root is not invisible. Bueno. Angie Funes, too, you have to use the square root. Elmer also. Bueno, the answer is 134.20 Newton. Okay? If you wrote 0.19, it's also good. Notice that you can do a rounding, okay? Now, if you didn't get this answer, if you got 131 point something, if you got 131 point something, maybe, and I'm saying that maybe because I'm not there with you, maybe you're using the calculator incorrectly, okay? Maybe that's the reason. So, your calculator, how you're gonna do it? Let me see if I have here the calculator, the digital calculator.